Sujatata. I am here to discuss questions on number systems. We have a set of 30 questions to discuss. Now, before we start, let me just quickly introduce myself. I am an aptitude trainer, also for MBA entrance tests, specifically CAT and other exams. I have taken CAT almost 9 times and have 99.9 in almost all of them. And in the quantitative section, I have a 99.99 percentile in 5 times total. So without further ado, let us start with the questions. I hope you will understand and enjoy them as well. Hello everyone. So here we have the first question. It says, if we multiply a number by 19, let the number be n. We multiply that by 19, so what do we get? We get 19n. And add the original number to it, so add back n to it. The result number, so that is equal to, is 1/3 of the square of the original number. So here we get 20n equals n squared by 3, cancelling out n from both sides. Since n is non-zero, we have n equal to, so option D. Next, number 2. You find the number of 3-digit numbers that are multiples of 3 or 5. So a 3-digit number means starting from 100 till 999. How many 3-digit numbers do we have? So we have 999 minus 100 plus 1. So that is 900 numbers. Why do we add 1? Because we are counting both the ends. For example, from 3 to 7, there are 3, 4, 5, 6, 7, 5 numbers. But if I just do 7 minus 3, I get 4. So I need to add 1. Now the quick way out of this is, since 900 is divisible by 3 and also by 5, we can simply say the number of multiples of 3 is 900 divided by 3 is 300 numbers. Multiples of 5 simply is 900 by 5, so 180 numbers. And 15, which is common to both these as well as these, because 15 is the LCM of 3 and 5. So 900 by 15, 60 numbers. So the number of terms that we need are 300 plus 180 minus these 60, because these 60 have been double counted in these two. That gives us 480 minus 60, 420 numbers in this. That's option B. Also, you are thinking like, why did I just do 900 by 3? The logic is, the first number that we have is 3 times 34, just crossing 100, till 3 times P33, just less than 1000, right? 999 itself. The number of terms would be 333 minus 34 plus 1, so that's 300. See, that's how we get that 300. For 5, it will be 5 times 20, and the last number would be 5 times 199, because 5 times 200 is 1000, so it's 1 less than that. So the number of terms is 199 minus 20 plus 1, so that is 180 numbers. See, we have got those 180. For 15, similarly, it is 15 times 7, all the way till 15 times 66, which is 990 itself. So that would give us 66 minus 7 plus 1, so that's 60. See those 60 here. So your answer is 300 plus 180 minus 60. So that's 420 numbers. Number 3 is asking how many times does 7 occur from 501 to 1000. So we look at 3 positions for 7. The units place, the tens place, the hundreds place. Now in the units place, the hundreds place can be filled by any of the digits from 5, 6, 7, 8 or 9, because the numbers start from 500 onwards. So there are 5 options for this and 10 options for this, because the tens place can be filled by anything from 0 to 9, so 10 options. So there are 5 times 10, 50 such occurrences of 7 in the units place. Now for in the tens place, in the same manner, here you have 5 options, 5, 6, 7, 8, 9. Here you have 10 options, 0 to 9. So here as well you have 5 times 10. So 50 times 7 occurs in the tens place. For the last case, The 7 is in the hundreds place. This place can be filled in 10 ways, 0 to 9, and the units place also in 10 ways, 0 to 9. So it's 10 times 10 here. So that's 100 such occurrences of 7. 7 in the hundreds place, 700 till 799. So total number of occurrences 50 plus 100. So that is 200 such occurrences. So that is option A. Let's move on to the next number. Then 4. What is the least number added to 962738 to get a multiple of 11? Now we need to figure out what is the remainder when this is divided by 11. So the divisibility rule for 11 says you will add the digits in the odd places. So add the digits in the odd places, subtract the sum of digits in the even places, and this output, if it is divisible by 11, then the number is divisible, else it is not divisible. If it is not divisible, whatever this result comes, that itself becomes the remainder, okay, when divided by 11. So let us look at the odd positions. So we have 8, 7 and 6. That's the first place, third place and the fifth place. Now these values is 8 plus 7, 15 plus 6, 21. Even positions are 3, 2 and 9. That's the second, fourth and sixth places. The sum of these are 9 plus 2, 11 plus 3, 14. The result is 7. The 7 is the remainder when this number is divided by 11. Hence, to make it divisible by 11, we need to either subtract 7 from this, but we are saying that we need to add something. So we add 4 to that, because then the result will be 11, means the remainder effectively will become 0. So adding 4 to the number will ensure that it is a multiple of 11. So option D. Next number, number 5. 5 prime numbers in the range of 1 to 50 are arranged in a decreasing arithmetic sequence. Okay. The product of the first 3 numbers is 935. So let us multiply or factorize rather. What number is multiplied to give you 935? So 5 times it's 187, which is 17 times 11. So 187 has factors 17 and 11, and 5 is the other prime. So your primes that we have got are 5, 11 and 17. Look at the gap. That's a gap of 6. So to maintain the arithmetic sequence, we must keep the gap of 6 going. So it would be 23 and 29. This would be my arithmetic sequence. Okay? But I have to arrange this in a decreasing order. So decreasing order would be first number, second number, third number, fourth number and the fifth number. That's the decreasing arithmetic sequence that we have generated. Just to make sure that we have done it right, if you actually multiply 23 and 29, you will get 667. So you can try it out yourselves. So the fourth number in the sequence is 11. Okay, that is option D. Okay, there is one slight typing mistake. It should be the product of the last 3 numbers here and the product of the first 2 numbers here. The logic being, since you are saying it's a decreasing arithmetic sequence, so it starts from the bigger number and ends with the smaller number. So 935 is a product of 5, 11 and 17. So those are the last 3 numbers in this series, not the first 3. So that was a small mistake in the typing. But you get the general idea how to solve this. Let's move on. Number 6. This is asking you how many 3s are there in 120. What this essentially wants to ask you is, what's the highest power of 3 in 120 factorial? But from the highest power of 3, so what we do is, from 1 to 120, every third number will give me a 3, right? So how many 3s will I get? 120 by 3, 40 times. 40 times 3 means we have basically got 3 to the power 40 because we are actually multiplying. Okay. So if I get 1 3 here, then another 3 from the 6. Basically the powers get added, we get 3 squared. In this way, we have got 40 times. So 3 to the power 40 is already there. None of the other numbers will ever give a 3, so you can just strike out those. Say 4, then 5, 119, those are all gone. So now you are left with 40 numbers, okay? After having taken out a 3 from each. How 40 numbers? As I said, there are 40 numbers here from 1 to 120 which are divisible by 3. So those 40, if I take out a 3, like for example, you have the numbers like 3, 6, 9, 12 and so on. If I take out a 3 from each, it becomes 1, 2, 3, 4 and so on. So we essentially have the first 40 integers now back. From 1 to 40, how many are again multiples of 3? So we will simply do 40 divided by 3 and we'll get 13 of them. That gives me 3 to the power 13. So out of those 40 numbers, if I have taken out the 3's and I have got 13 3's, now I am again left with, just like in the previous case, I am again left with the numbers 1, 2, 3 all the way till 13. Again, out of these 13 numbers, how many of these will be divisible by 3 again? So that will be 13 divided by 3 and that will give me 4 times. Okay, so we got 40 times, we got 13 times, we got 4 times. And finally, out of these 4 numbers, which are 1, 2, 3, 4, there will be one more 3 left. 4 by 3 is 1, so that is that one. So how many have we got? We have got 40 first, then 13 more, then 4 more, and then 1 more. So that's 53 plus 4, 57 plus 1, 58. That means there are 58 3's, and hence the answer is option A. So the highest power of 3 is 3 to the power 58. Number 7. It says the number 9A2B0 is divisible by 35 and by 11. So for 11, the divisibility rule is sum of the odd positions by sum of the even positions. So sum of the odd positions 9 plus 2 plus 0. So that's 11. Minus sum of the even positions A plus B. Which should be divisible by 11. So that means A plus B must be divisible by 11. Because the logic is 11 minus what will make it divisible by 11. So 11 minus 11 itself will make it divisible by 11. Or 11 minus 22 will make it divisible by 11. Or 11 minus 0 will remain divisible by 11. But non-zero digits A and B is mentioned, so they can't be 0. But A and B maximum can be 9 and 9. That's 18. That means 22 is not a possibility. So A plus B, the only possibility is 11 itself. So we have A plus B as 11. Now, it's also divisible by 35. 35 means 5 and 7. Okay? 5 is anyways divisible because it is a 0 at the end. We just need to check the divisibility for 7. So there is a divisibility rule for 7 as well, where we use seed numbers. Rather than introducing that, a simple way of doing this would be, what are the possibilities which add up to 11? So we have 2 and 9, 3 and 8, 4 and 7, 5 and 6, 6 and 5, 7 and 4, 8 and 3, 9 and 2. Okay? These are the possible cases of A's. So if you had wanted to figure out what is the value of A and what is the value of B, so what you have simply to do is 9, let's put it 2 and 9. So 9, 2, 2, B is 9, 0. And check, is this divisible by 7? Okay. It is or it is not. Okay, then move on to the next one. Then move on to the next one. Try out these, you will get the exact values of A and B as well. But let's focus on what the question is just asking. Just asking what is A plus B. See, we have already got that long back, right? A plus B is 11. So I was just showing you, in case if they had asked you how to find out what are the values of A and B, how we would have done. Here it is just option C. So 11 is the answer. So what was the logic? A plus B is divisible by 11. It cannot be anything more than 11 because you will get 22 next. 22 is divisible by 11. So 11 plus 2 is 22. 22 plus 2 is 24. 24 plus 2 is 26. 26 and 5, 7 and 4, 8 and 3, 9 and 2. Okay? These are the possible cases of 22 is not possible because 9 plus 9 maximum possibility is only 18. Next question. So it says if the numerator of a fraction is decreased by 2, let's take the fraction as a by b. So we have numerator decreased by 2, denominator increased by 4. This result is half. That gives us an equation. B plus 4 is 2a minus 4. So in other words, it is basically 2a minus b equal to 8. Number 1. Second, the denominator is decreased by 4 and the numerator is increased by 4. So in numerator plus 4, denominator minus 4, the result is 3 by 2. So we get 2a plus 8 equal to 3b minus 12. So that gives us 2a minus 3b is equal to minus 20. Or in other words, we can do minus 2a plus 3b is plus 20. Now these two equations 1 and 2. So on adding them, 2a cancels out. We get 2b equal to 28. So b is 14. And hence 2a minus 14 is 8. So 2a is 14 plus 8, 22. So a becomes 11. So the question is, find the fraction if 1 is added to the numerator and denominator. So your fraction is 11 by 14. But if you add 1 to both, you get 12 by 15. Cancelling out the 3, you get 4 by 5. So your answer is 4 over 5. So that is option B. Next. Number 9. There are 2 clocks in a home. One clock rings after every 36 and the other one tolls every 90 seconds. So they will ring together or toll together after the LCM of 36 and 90. So now factorize out. 36 is 2 squared, 3 squared, and 90 is 2 ones. 3 squared, 9, so 18, and 5 ones. So each common multiple would be 2 squared, 3 squared, and 5. That is 180 seconds. So if they have, so 180 seconds means basically 3 minutes. So if they ring for the first time at 11:05, they will toll again together after 3 minutes. So it's 11:08. That is option C. So 9 is option C. Next question. The number 3a779b is divisible by both 6 and 5. What is of a and b? So if it has to be divisible by 5, then b has to be either 0 or 5. Now it is divisible by 6 as well. The 6 means it's definitely divisible by 2 and 3. If it has to be divisible by 2, it has to be even. So b cannot be 5. So for sure it is 3a7790. Now you have to check the divisibility of 3, which is the sum of digits. The sum of the digits is 3 plus 7, 10 plus 7. So that is 17 plus 9. So that is 26 plus 0. So 26 plus a is divisible by 3. So a has to be 1. So that gives you 27, or the next multiple of 3 will be 30. So a can be 4 also. Or the next multiple of 3 is 33. So a can be 7 as well. Okay, so a's value can be either 1 or 4 or 7. But b for sure is 0. So what are the possible, they're asking possible values of a and b. So 1 and 0 is not there. 4 and 0 is not there. 7 and 0 combination is there in the answer. That is option B. So answer to 10 is option